Hello all, welcome back to my channel. I have a question for you all today. How many of you think that statistics is a nightmare or you just got afraid by listening to statistics? Well, believe me, statistics is not at all a nightmare. So, to learn statistics in a very simple way, join me with a web series on statistics with inner minds. So, what is statistics basically? Statistics is nothing but it just laid the foundation of data science and machine learning. Yes, you heard it correctly. Without statistics, data science, data analytics, and machine learning is not at all possible. So there's a fun fact by Mark Twain. He says that there are lies, damn lies, and statistics. What does it actually means? He says that if you collect data about any particular item, then you should know what that data is offering to you, and then only you should apply statistics to it. If you don't know or don't understand what that data is or what that data can infer to you, then applying statistics to it can be dangerous to anyone. So, today's agenda is introduction to statistics, importance of statistics in data science and machine learning, data in statistics. So, what is the data, types of data, and sources of data, and what are the different types of statistics. So, let's begin with what is statistics. So, statistics is the science of conducting studies to collect, organize, summarize, analyze, and draw conclusions from the data. Let's understand this with a very simple example. Let's say you want to know how good the Apple's iPhone are doing in India. So, what will you do? You will start collecting the data regarding to iPhone. So you will see what is the sales of iPhone in different cities, in different states. So what are the different discounts that being offered in iPhone? What is the current price of iPhone and various other factors. So you can collect the data at city level, at district level, at state level, and you can go as much granular as you want to do. So once you are collected with the data, then what will you do? You will summarize that data, you will analyze it, and then you will draw the conclusion. Your conclusion could be that Apple is doing a pretty good business in India and iPhones are selling like a hotcase. So, to draw these kind of conclusions, you have to summarize and analyze your data. And for that, you need statistics. So, this entire process is called as statistics. So, what is the importance of statistics in data science? So, once you are collected with the data, you will apply statistics on it. You will get some knowledge or some information. On that information, machine learning algorithms will be applied, again, in which statistics is involved. Because machine learning algorithms are based on statistics only. After applying machine learning algorithm, you will get some pattern, and that pattern could be used in prediction, in clustering, or classification. To understand these terms, please refer to my previous video. The link has been attached to it. So, another fun fact by Carl Pearson. He says that statistics is the grammar of science. What does it mean? If you want to learn English or if you want to learn French, if you want to learn any language, then what you need? You need to understand the basic grammar of that particular language. Yes. So similarly, if you want to learn data science and if you want to learn machine learning, then statistics is the grammar for that particular data science. Yes, statistics is really important for data science. So statistics has been applied in diverse fields. It could be applied in medicine, it could be applied in business, it could be applied in weather forecasting, stock market, health and social sciences. In medicine, if you want to find out the drug cure rate over 100 patients, then what are you doing? You are applying statistics to it. If WHO wants to find out the epidemic spread in the month of July, then what will it do? It will infer from the previous recorded data, again, statistics. And if you want to find out the improvement of TB cases across the world, then again, you're applying statistics. Again, in the another example like stock market, if you want to understand the performance of stocks over time, or you want to predict the average price of an automotive stock, or you want to study the stock of Infosys over the period of the last 52 weeks, what are you doing? You're just applying statistics. Apart from these examples, if you want to just find out the average marks of a particular class in our college, then again you're applying statistics. Yes, you heard it me right. So every day we are applying statistics without knowingly or knowingly. So to apply statistics, what we need is data. So data is a collection of information such as facts, numbers, words, measurements, observations, or even just description of things. So if I collect data about a particular item, let's say rainfall, the measurement of rainfall in last 2 days, that is data. But if I want to find out what will be the rainfall in next 2 days or next 2 weeks, that is something which is called as information. And information is being collected by applying statistics on the data. So data can be collected from two types of sources. Either it could be primary data or it could be secondary data. So primary data is the one that the researcher will collect on its own by addressing the population. It could be in the form of interviews, it could be in the form of observations, it could be in the form of questionnaires, case studies, and focus group discussions. So whatever primary data we collect directly by interacting with the audience or with the population at hand, we call it as primary data. Whereas already recorded data is called as secondary data. So if I collect the data from the previous research, if I collect the data in the form of diaries, in the form of letters, in the form of web information, or in the form of stock data such as census data, then I will use that data for my research which has been already collected, that is called as secondary data. Data can be of many types. It can be quantitative data, qualitative data, interval level data, or ratio level data. Quantitative data is something which can be measured in the form of numbers. It is of two types, discrete and continuous. If I want to find out how many cars a person has, then I will say a person has either 2 cars or 3 cars. I will never say that person will have 2.5 cars. Similarly, if I want to measure the height of a person, then I will always say that the height of a person can be 5.2 feet, it can be 4.9 feet, but it is not necessary that the person's height is either 4 feet or 5 feet. So, if I'm representing my data in the form of whole numbers, then it is discrete data. And if I'm representing my data in the form of decimal numbers, it could be continuous data. Next is qualitative data. Qualitative data is something which cannot be measured in the form of numbers. The categories are nominal and ordinal. So if I want to categorize my data into different categories, I will use nominal data. For example, gender. I can categorize it into two categories, either male or female. But if I want to represent the order in my data, that kind of data is ordinal data. For example, if I want to buy a t-shirt from the market, it could be in size small, it could be in medium, it could be in large. So what is it representing? The size of the t-shirt is present in the different orders, small, medium and large, where small is lesser than medium, medium is lesser than large. So it represents the ordinal data. Next is interval level data. If I say that the temperature at 10 a.m. was 29 degree and the temperature at 11 a.m. is 30 degree, then what can I say? I can say that temperature has risen with an interval of 1 degree at 1 hour of interval. So that is kind of interval level data. Next is ratio data. If I want to measure the weight of a person 2 months before and 2 months after, then what I can do, I can find out the ratio of that particular weight. So that is ratio level data. For more detailed understanding on types of data, please refer to my previous video. The link has been attached to it. Next comes on statistics. So statistics is basically of two types, descriptive and inferential. Descriptive means when we want to describe our data, and inferential means when we want to infer something from the previous data. So stay tuned to my channel for next video in which we'll discuss what is descriptive statistics, what is inferential statistics, various types of descriptive statistics and inferential statistics. So please stay tuned to my channel, subscribe to my channel if you have not done it till now, and please wait for the web series on statistics. Thank you all.